Let's start the lecture. So in the previous lecture, we have seen various type of rain gauges. Okay. So we have classified the gauges into two types. So basically what is a rain gauge? So rain gauge is a device which is used to measure the precipitation. The rain gauge measures the depth of precipitation, or we can say it measures the precipitation. So in our case, we will be seeing precipitation means mainly we will be dealing with the rainfall. Okay. Now, so coming back to the main concept of precipitation. Okay. So today what we are going to see is, give the heading, optimum number of rain gauges. Optimum number of rain gauges. Okay. So what is the meaning of optimum number? So in a particular area, there should be a minimum number of rain gauges to give the required degree of accuracy. Okay. So just pay attention here. Let's say this is an area. Okay. So in this area, we want to measure the precipitation. So in the case 1, okay, so what we'll do, we'll take two areas. So these are same. Okay, so these both areas are same. Now in this first case, what I am doing is I am deploying here four rain gauges. This is 1, 2, 3 and 4. So what this rain gauge will do, this will measure the amount of precipitation, that is amount of rainfall. Let's say this is measuring 10 centimeter, this is measuring 12 centimeter, this is measuring 11 centimeter, this is measuring 8 centimeter. Okay, so for this area we have got here four readings. Now for the same area, let's say instead of four rain gauges, if we are deploying, let's say 9 rain gauges, okay, or we'll take it 10 rain gauges. So in the first case, for the same area, 4 rain gauges are used. In the second case, 10 rain gauges are used. So accuracy of data will be more in which case? In the first case or second case? The accuracy, what I am talking here is accuracy of data, accuracy of rainfall or precipitation data. So where will be the more accuracy? Accuracy will be more in this second case. Okay, as compared with the first case. Why accuracy will be more? Because the number of rain gauges are more present here as compared to the first one. But we cannot just simply keep on increasing the rain gauge, because the cost will also increase. Okay, so there has to be some minimum number of rain gauge for which we can get a required degree of accuracy. Okay, so once again I am using the term here, the number of rain gauges depends upon the accuracy of data that is required. If we want more accuracy, then the number of rain gauges will be, or we can say it has to be increased. But this is all theoretical point of view. If you want to find it out mathematically, then some equations are given, we have to use that equations and find out the optimum number of rain gauges. Okay, so for now we will be using small n to denote the optimum number of rain gauges. Okay, so it is a number like 4, 5, 6, so that number we have to find it out. So how to find it out? So first write down these formulas. So the first formula is mean of rainfall. Mean of rainfall. So this we will denote with P bar. Okay. So P is precipitation or rainfall, and this bar represents the mean. This means mean nothing but it is means average. Okay. So this P bar formula is P1 plus P2 plus P3 plus so on divided by N. Okay. So this is the number of rain gauges which are present. So in the first case, how many values are there? See, this is P1, P2, P3 and P4. What is the N value here? N is equal to 4. Number of rain gauges are 4 present here. P1 value is 10 centimeter, P2 is 12, P3 is 8, P4 is 11. So we can find out the mean. Okay. So this is the value, which is the formula for mean of rainfall. Second formula, standard deviation. Standard deviation. So the standard deviation, we are denoting it with sigma, and the formula for the standard deviation is square root of summation of pi minus p bar whole square divided by n minus 1. Okay, so this is the formula for standard deviation. Now let's go with the third formula. The third formula is coefficient of variation. Coefficient of variation. So it is denoted by CV, and this CV, it is equal to 100 sigma divided by p bar. 100 sigma by p bar. Write down the last one. Now this last formula is showing us optimum number of rain gauges. So this value we have to find it out, that is n value. This n is, it is equal to CV divided by E, CV divided by E whole square. Okay, now this CV means the coefficient of variation, so we can find it out by 100 sigma by p bar. This 100 and sigma, these both are present here. This E value is new. Okay, so write it down. What is the meaning of E? So this E stands for allowable percentage error. Allowable percentage error. So we can also write it as 100 minus percentage accuracy. Okay, so now you can see here there is an accuracy term which is coming. So let's say for this example only, if you are taking, let's say we want 100% accuracy of the data. See, I told you that if you want to get more accuracy, the number of rain gauge has to be increased. Okay, so accuracy is expressed in terms of percentage, like we want 90% accuracy, 100% accuracy. So let's say we want 100% accuracy. That means the data has to be very very accurate. There has to be no mistake in the data. Okay, not a slight mistake. So what we'll do, you substitute this 100% in this formula. So 100 minus 100, what it will be? E value. This E will be equal to 0. Substitute this E is equal to 0 in this equation. Optimum number of rain gauge n is equal to CV divided by 0. That means, see, if we substitute here 0, what it will be? CV divided by 0 whole square. Okay, so anything divided by 0, this will be infinite. That means the number of rain gauges which has to be present in the particular area to get the 100% accuracy is infinite. That means there is no, there is a, like we cannot say that it any number. The number of rain gauges that are required are infinite to get the 100% accuracy. Generally we don't go for the 100% accuracy. So based on the percentage accuracy which is required, it will be given in the problem. So you substitute it here, and from that you will get the value of optimum number of rain gauges. Okay, I hope it is clear now. So there can be a slight confusion between the value of n here, because see, here only we are using the same m value. So what we will do, we have denoted the optimum number of rain gauges with small m. Okay, and the number of rain gauges which are actually present, we will denote it with capital M. Okay, or we can say small m. So n and m. So here the values you have to take up to pm, and this will be divided by m. So this m are the total number of rain gauges present. The n, what is n? N is the optimum number of rain gauges required. So here also we will be using m. Okay, so don't get confused between n and m. So I am writing it here. This m is actual number of rain gauges present. Actual number of rain gauges present. The n is optimum number of rain gauges required. Okay. Now let's take the example of the first case here. So in the first case, what is the value of number of rain gauges actually present, that is m value. So for case 1, the m value is the m value is 1, 2, 3 and 4. So m value is 4. Okay. Now let's say the n value which we have got. What is n value? Optimum number of rain gauges. How to calculate it? By using these 4 formulas. Okay. Let's say this value is coming. This value is coming as 2. Okay. If the value is coming as 2, that means we can write n is less than m. Correct? That is optimum number of rain gauges which are required is less than actual number of rain gauges which are present. See, here only the problem will arise. Okay, so in question in examinations like GATE and ESE, you will get problems here. So pay attention here properly, try to focus. See, in the first area, okay, that is the first case which we have seen, the optimum number of rain gauges which are required. How many gauges are required? 2 gauges are required. Okay, so in the first case, how many optimum gauges are required? 2 gauges are required. But how many gauges are present here? 4 gauges are present. That means, is there any requirement to add any more gauges on this area? No. See, minimum 2 is required. But how many are present there? 4 are present. So no extra gauges are required. I hope you have got the point. So that only we have to write here. If n is less than m. Okay. So this is the case number 1. That is, actual number of rain gauges which are present are more than optimum number. Then no need of extra gauges. No need of extra rain gauges. See, here the problems will come. Okay, so pay attention to this concept properly. Okay, now this was the first case. Now let's take the case 2. Case 2. The case 2 will be opposite of this. That is, the optimum number of rain gauges which are required are more than the actual present. So let's take the data here. Let's say the n value. Okay, we'll take the case 2 here. So in this case 2, how many gauges are there? In this, 10 gauges are present. Okay, so m value is 10. So we have to take the n value more than m value. So let's take it as 15. Now try to interpret this data in this. So n value is 15. See, in the second area, what is the optimum number of rain gauges required? 15. How many rain gauges are present here? Already present 10. Okay, so required is 15, but present, already present here is 10. So how much more we require? We require 5 more. Okay, we require 5 more rain gauges to come to the optimum number of rain gauges criteria. Okay, so here in this case, the rain gauges are not sufficient. Rain gauges are not sufficient. Okay, so extra needed. So this is asked in the question. Okay, so extra rain gauges required. Extra rain gauges required. So in this case, how much extra rain gauges were required? 5. How to calculate this 5? Can we calculate it like this? N minus m. Correct? So extra number of rain gauges which are required is calculated as n minus m. So same thing, write it down here, n minus m. That's it. Okay. So once again, we'll quickly revise what we have seen. So in this class, we have studied about the optimum number of rain gauges. Okay. This optimum number of rain gauges is decided based on the accuracy of rainfall data required. If you want more accurate data, then number of rain gauges will be required will be more. So how to find out the optimum number of rain gauges? You can use the formulas here which are already given. Okay. Once you get the optimum number of rain gauges, you have to find it out whether on the site optimum number of rain gauges is present or not. So in the first case, we have seen the optimum number of rain gauges that is required is 2. However, on the site there are 4 rain gauges which are present. That means there is no need of extra rain gauges. The criteria is already met. However, in the second case, the optimum number of rain gauges that were required was 15, but on the site only 10 rain gauges are present. So to come up to the desired accuracy, we have to increase the number of rain gauges. So how much we have to increase? We have to increase it by 5 units. So that n minus m is called as the extra rain gauges required. So this is all about the calculation part. Numericals we see in the next videos.